Welcome to another session with Ms. Taylor. Again, we're looking at empirical molecular formulas. This problem is slightly more difficult. Alright, we are looking at strychnine, and they've given us percentages for carbon, hydrogen, nitrogen, and the rest oxygen, which means we actually have to subtract to figure that out. Okay, so let's start by listing what we have, and remember, if you're given percentages, just change it to grams because we assume 100 grams of sample and say our percentages are equal to the amount of grams. So we should have 75.42 grams of carbon, I'm jumping ahead, 6.63 grams of hydrogen, 8.38 grams of nitrogen, and then if you say 100 minus the percentages you were given, you should get 9.57 grams of oxygen. Now the first thing you need to do to these is convert them to moles, because formulas are actually mole ratios. So before we can figure out that mole ratio, we're going to have to first convert all of our grams to moles. So I'm just filling them in first, and molar mass of carbon is 12.011 grams. Molar mass of hydrogen is 1.00794 grams. Molar mass of nitrogen is 14. And then molar mass of oxygen is 16. Okay, so for carbon we have 6.279 moles present. For hydrogen we've got 6.578. For nitrogen we've got 0.599. And for oxygen we've got 0.598. Okay, now we're not done yet. Our next step is to divide all of these by the lowest amount of moles present, which will be the 0.598. Now these two are going to be 1.000 or something. So we can safely say they're 1. Carbon and hydrogen, not so fast. Carbon is actually 10.48 and hydrogen is 10.98. Now, I know normally you would look at this and say, well, we could round that up to 11. Okay, and you can. You'll get it mathematically, that's fine. But this 10.48, not so much. Okay, you can't round that up to 11, not safely. So because of the carbon, we're going to have to multiply all of these by a number so that we get a whole number. And I know it looks weird, but if we multiply that number by 2, we'll get 21. For that number, we'll get 22, and of course for these two, we'll both get 2. So the empirical formula for strychnine is C21H22N2O2. Now they also asked for the molecular formula, and they said that the molar mass of the actual compound is 334.41 grams per mole. Now to get the molecular formula, we're going to have to do the actual divided by the empirical. And surprise, surprise, it is actually the same, so the molecular formula for strychnine is the same as the empirical formula, C21H22N2O2. So big thing with these problems is to remember your steps. If you're not given grams, pretend that your percentages are grams, convert to moles, divide by the smallest number of moles so that you hope you get a whole number, a set of whole numbers as for your mole ratio. And if you don't, then multiply all of them by a common factor so that you get a nice set of whole numbers. Because remember, when you're looking at a formula, you're saying that moles of these elements combine to give 1 mole of the compound. They don't combine by masses. So just like you got the mole ratio when you were doing stoichiometry, there's the foundation for mole ratio. Hope you enjoyed it.